This is a design for a hydroponic robotics system. If you look at it carefully, it's designed to grow plants inside during the winter when outside's not the most fertile to be grown. If you look at it, the bottom is going to consist of a bucket that's going to hold water and nutrients. The middle neck of it is going to be where the plants are held. And then the top is going to have a few pieces also. It's going to have a water pump on the top left that's red, and an Arduino top right, which is blue. Furthermore, looking into this, if you look on the bottom, there are going to be LED lights to keep the plants nice and sunshiny, to keep it all growing. And last but not least, if you look at the inside, there are going to be hoses that bring the water all the way up through the middle to water the plants. The coding for this is going to be this. The circuitry in the coding is going to be this. If you look at it, it's going to have an Arduino, which is going to be supplying the code. It's going to have the potentiometer on the bottom left, a moisture sensor. It's going to have a switch, and last but not least, a button. All those are going to be the inputs. The outputs are going to be a DC motor that's going to be simulating a water pump, and then an LED light, which is going to be simulating a light strip. Furthermore, going on to the code is going to be as following. It's going to be in C++. INT is going to be representing the basic setup values for the different inputs. Pins are going to be set up using void setup. Those are going to be the specific pins that are going to be used. On the bottom is going to be the void loop, where all the information is going to be happening. All the coding is going to actually cause everything to go into effect. This first section of the loop is going to be where the inputs are going to be putting the values in, how they're going to be setting up. The potentiometer is going to be set on a scale from 0 to 3,600, which is going to be a time limit of an hour. The potentiometer is going to be set in seconds. Switch is going to be just whatever the value is going to be. The moisture sensor is going to be set up 1 through 4 to set up into quarters, and the button is pretty much just going to be high and low. Serial prints are going to be printing anything that's on the bottom over here. All the inputs, all the information is going to be put down there. And last but not least, the water pump is going to turn on when the switch is all the way on, and the moisture sensor is anything but 0, which is going to be set to about a third. Once those two criteria are met, the digital write of pin 11 is going to turn on for 5 seconds. After that, there's going to be one for the LED. It's going to turn on for if the switch is on, and if the button is pressed, it's going to turn on for however long the potentiometer is set for. And then both of them are going to turn off at the end. As shown, when we turn on the simulation, nothing's going to work without the switch turning on, so everything's being played with. Nothing's going to be able to be turned on or off. But as soon as we turn on the switch, if the moisture sensor goes about above a third, the DC motor is going to turn on, start working. If the moisture sensor turns off, it's not going to work. And then if you turn on the potentiometer, it's going to go and turn on the light for however long it's pressed for. How many seconds it's set for.